So today I'm covering the rest of the problems from Module 3 Test Review. So we're going to learn from problem number 23 to 33. So this is part 3. I have posted part 1, part 2, and part 3. So number 23. So we have to write the polynomial f of x for the given conditions. So the conditions are degree 3 polynomial with zeros, -3, 2i, and -2i. So the answer is, since -3 is a 0, that means x plus 3 is a factor, and 2i is a 0 means x minus 2i is a factor, and -2i means x plus 2i or is a factor. So this all three are factors of f of x. So how do we find f of x? We have to multiply all the three factors. That means x plus 3 times x minus 2i times x plus 2i. Okay, so first I'm going to multiply x plus 2i and x minus 2i because they are kind of imaginary numbers, so that makes it easier. So we get x squared plus 2ix minus 2ix minus 4i squared. So middle terms get cancelled. So we get x plus 3 times x squared minus 4 times, remember I squared is -1. So we get x plus 3 times x squared minus of minus becomes plus. Now we have to FOIL this binomials. So x times x squared is x to the third plus 3x squared. I'm just writing the polynomial in the descending order, plus 4x plus 12. So this is our final answer. So the f of x is x cubed plus 3x squared plus 4x plus 12. Excuse me. Number 24. We have to list all the possible zeros. Possible rational zeros. For the polynomial, so by rational zero theorem, we have factors of that are possible rational zeros are factors of 15 over factors of 1 because 15 is the constant. 15 is the constant and 1 is the leading term. So we have to find the factors which are 1, 3, 5 and 15 with plus or minus. And the denominator is just 1, so it's going to be plus or minus 1. So when we divide everything by 1, we get the numbers itself. So these are the possible rational zeros. Again, the same question, we are going to write all the possible rational zeros. For the polynomial g of x. So the same thing, we have to first write the factors of the constant, which is 14 over factors of the leading term, the leading coefficient, which is 4. So we have to first put the factors of 14 over factors of 4. And writing all the factors of 14 with commas over factors of 4. Now I have to divide all the zeros. You just divide, take all the numbers in the numerator and divide by the denominator. If any number repeats, you don't have to write twice. Just write only once. So this is the list of possible rational zeros. Number 26. Now the question is, we have to find all the zeros. We are not finding the rational zeros. We have to find all the zeros. So in order to find the zeros, you can write down all the possible zeros, rational zeros, and we have to use testing. Like you have to take one number at a time and then check if that is a zero. Or you can enter on your calculator as well. Or I'm going to just write down the numbers. It's going to be just the factors of 6 only because the denominator is 1. So now I'm going to just take one number. For example, I'm going to try 3. You can do that by entering on your calculator. So that's how I got for the polynomial. Sorry, I forgot to write the polynomial. So -5, 4, and 6. Bring this one down. So 3, -2. So it works. I got 0 as my remainder. That means 3 is a 0. So that is our first 0. So to find the next one, I have to solve this quotient. So I'm going to factor x squared minus 2x minus 2 equal to 0. So there are no numbers, factors of 2 that adds up to -2. So I'm going to use quadratic formula. So you can always use quadratic formula. So A is 1, B is -2. The safest and easiest way to solve any quadratic function is using quadratic formula. So we are getting 12 over 2. So we can factor the 12 into 4 times 3. We learned this one as well. And square root of 4 is 2, so I'm taking it outside. And we can divide everything by 2. So 2 over 2 is 1. 2 over 2 is 1 again. So we get 1 plus or minus square root of 3. So the zeros for this problem, I'm writing down the answers, is 3 and 1 plus or minus square root of 3. Next, I'm moving on to 27. So again, it's the same question. Find the zeros. We have to find all the zeros of this polynomial f of x so we have to write down the factors of 17 over factors of, this is part 1, factors of 7, this factors of 17 over factors of 7. Both are prime numbers, so you get only the 1 and the number itself. So the final list is 1 over 7 and 17 over 7. This is the answer for part 1. Next, part 2, we have to test if x equal to 1 is a 0. We can do this in different ways, but you have to find the remainder. So I'm going to do 1, I'm going to divide this by 1. So I'm getting negative 96 as my remainder. So it's not, x equal to 1 is not a 0. You have to get 0 as a remainder. So it's not a 0. Okay. So next one, we are going to do test if x equals -1, that is part 3. We have to check if x equals -1 is a 0 or not. So I'm going to divide the polynomial by -1. Mhm. So the remainder is 121. So x equals -1 is not a 0. So part 4, we have to test if x equals 1/7 is a 0. So we're going to divide this polynomial by 1/7. So multiply, so we get 1, 0, 0. So we get -119. And when you multiply, you get -17. Yes, it is a 0. So the answer is yes. X equals 1/7 is a 0. Okay. So by factor theorem, this was part 5. By factor theorem, x minus 1/7 is a factor, right? So the quotient here is, this is constant, and this is x and x squared. The quotient is also a factor. The quotient, which is 7x squared minus 119, is also a factor. So now we are the actual question is we have to find all the zeros. So we have to find the rest of the zeros. So this is our first 0, right? And we have to solve for x in this equation. And divide by 7. So we get x squared equals 17. So x is, by taking square root, we can get the x. So x equals plus or minus square root of 17. So the zeros are 1/7. So I'm going to write on the top the answer. The zeros are 1/7, square root of 7, and minus square root of 7. So this is our final answer. Oh, sorry. Let's see if we go back. I'm sorry. I forgot to put it's 17, not 7. It's 17 and 17. I'm sorry. Next, number 28. Number 28. Write a polynomial. So we are going to write a polynomial of degree 3 with the conditions, with the zeros, negative 8i and 8 over 7. So we know that if negative 8i is a 0, by conjugate theorem, 8i is also a 0. Okay, so how do I write f of x? F of x is going to be, I have to write x minus 8i, x plus 8i, and for this one, I can say 8x minus 7 is a factor. Okay, so I'm going to write 8x plus 8x minus 7. Oh, it's 7x minus 8. I don't know why I'm doing this. Because it's 8 over 7. The denominator is the coefficient. Now we have to FOIL this. Times 7x minus 8. And these two get cancelled. So we get x squared plus 64 times 7x minus 8. Now FOIL again. So we get x to the third. 7x to the third minus 8x squared plus 448x minus 512. So let's rewrite them in the descending order. So this is our final answer. So next one, number 29, is we have to write the domain of the function, the rational function. Of the function, we have to write in the interval notation. So whenever you have a rational function, to find the domain, you have to check what makes the denominator 0. So the denominator is 0 means x is going to be 3. So this value 3 is not in the domain. Basically, x minus 3 is not equal to 0. That's how we define the domain. So the domain is all numbers. So the domain, if you look at the number line, all numbers that are up to 3, from negative infinity to 3 and 3 to positive infinity. So it's going to be negative infinity to 3 union 3 to infinity. So that is the domain of this function. Number 30, the same question, we have to write the domain of the function. For the function p of x equals 19. So when you set that to find the domain, if set equal to 0, subtract 64, we are going to get an imaginary numbers, which means that there are no numbers that's going to make the denominator equal to 0. So plus or minus. So that gives x equals plus or minus 8i, which is an imaginary number. That means none of the numbers is going to make the denominator 0. So the domain is all real numbers. So you can say, like it says you have to write the answer in the interval format. So the answer is negative 8 to positive 8. Number 31. So we are almost there. Again, we have to, this one is we have to find the vertical asymptotes. So I have covered this section 3.5 already. So to find the vertical asymptotes of the function, we have to set the denominator equal to 0. So the vertical asymptote is t minus 6 equal to 0. Now add 6 both sides. So t equal to 6 is the vertical asymptote of this function. Okay, so again, we have to find the vertical asymptote of the function f of x equals x plus 1 over 3x squared plus 14x minus 5. So again, we have to do the same thing. We have to set the denominator equal to 0 and factor this. So now we are going to use the AC method because A is 3, C is -5, and when you multiply A times 3, we get -15. You have to find the factors of -15. When you add them, it's going to give you 14. So what are those two numbers? 15 and -1. When we add 15 minus 1 equal to 14, which is the B. So I'm going to split this 14 into 15x minus 1x minus 5 equal to 0. Now use grouping to factor this. So we get, I'm going to write it down again. Minus 1x minus 5 equal to 0. So let's group first, second, third. So 3x is common, so we get x plus 5. In the second one, -1 is common. Okay. X plus 5 is common. So we take the x plus 5. And the leftover is 3x minus 1. Now we have to set each one equal to 0 to solve for x. So x plus 5 is 0, or 3x minus 1 is 0. Get the x by itself. So we get x equals to -5. So this is our next 0. And x equals 3x equals 1. So x equals 1/3. This is our zeros. So the zeros of the denominator are -5 and 1/3. So now what happens? So the asymptotes, the vertical asymptotes, are x equals -5 and x equals 1/3. Because asymptotes are lines, you have to write the answer like x equals, because it's a vertical line. And we have reached the end of this review. So number 33 is we have to identify the horizontal asymptotes. So find the horizontal asymptote, which is HA. That is part A. Part B, we have to check if the graph of the function, has a, if it has a horizontal asymptote, then we have to find the point if any, where the graph crosses the horizontal asymptote. So let's do the first one. So the function given here is x plus 7 over 3x squared plus 6x minus 5. So we have to find the n and m. Remember, we have to find the degree of the numerator, which is 1. The degree of the denominator is 2. And n is less than m because 1 is less than 2. Right? When the n is less than m, y equal to 0 is the horizontal asymptote. Okay. Now, to find if the function graph, the graph of the function crosses the horizontal asymptote, we have to set s of x. This is the function given. So to find the crossing point, at which point it's going to cross the horizontal asymptote, we have to set this equal to 0. Not always, because the horizontal asymptote is 0. See, we're going to substitute here. If the number is 2, then we have to substitute 2. So I have to solve this equation. How do I solve? You have to multiply both sides by the least common denominator, which is 3x squared plus 6x plus 5. Then we'll multiply both sides by that. So we get 0 on this side. On the other side, these two get cancelled. So I get x plus 7 equal to 0. That gives x equals -7. So the point -7, the answer for this question is -7, 0 is the point where it crosses the where the graph crosses the horizontal asymptote. So that's the end of the test review. I hope it helps you. I'll see you next time.